Okay, so going back to the beginning here, how would we solve something like this? Yeah, so what would the what would the two steps be in order? Subtract 64 and then square root. And we know that because we can point to a single x, and so we're just going to be isolating the variable using inverse operations, right? Good. So first step, we're subtracting 64. Every step I should be able to cancel something if I'm isolating a variable, right? So I get x squared equals negative 64. You guys told me correctly I'm going to square root both sides to cancel the squared. And so I get my solutions. X equals what? Plus or minus. When I square root both sides, have to include a plus or minus. And what's the square root of negative 64? 8i. So there are my solutions. Positive 8i, negative 8i. Good. Okay. How about that one? Can I isolate the variable? Yeah, I can point to a single z. I can. So what would the steps be in order? What do I do first? Add 4, divide by 2, square root. There we go. Okay. So I cancel. Then you told me divide by 2. That's good. So I cancel. And that gives me z squared equals 2. Last step, square root to cancel the squared. And I finally get z equals what? Square root of 2? Plus or minus. Plus or minus square root of 2. Good? Okay. Okay, how about that one? Give me thumbs. Can I isolate the variable this time? I can. I can point to a single x. Okay, what comes first this time? Square root. Yeah, because the rest is inside the parentheses, right? The stuff that's being square rooted. So first step, square root both sides to cancel the squared. That gives me x plus 7 equals what? Plus or minus. Good. Plus or minus 2. Last step, subtract 7. Now, where do I put on in front of? Good. In front of the plus or minus. So we're going to subtract 7, and we get x equals negative 7 plus or minus 2. Now, we don't want to leave it like that because I can simplify those answers. So if I take the plus sign, what do I get? Negative 5. Negative 7 plus 2 is negative 5. If I take the minus sign, negative 9. Those are my two solutions. Okay? Okay, this one, I can't point to a single x, so I can't isolate. There are no magic numbers. I would prefer to use magic numbers if I could, but unfortunately there aren't any, right? That multiply to negative 3 and add to negative 1, so I've got to use the quadratic formula. So first of all, remind me about that. If I've got a quadratic equation in standard form, ax squared plus bx plus c equals 0, then x equals what? Negative b plus or minus. Good, all divided by 2a. Make sure you put that division bar under everything, not just the square root, the whole thing, right? So now I can just plug and chug. Using the quadratic formula, what would go on top? What's negative? What are my values of a, b, and c? 1. What's c? Okay, so what's, if I plug in then, what's negative b? 1. Okay, what's b squared? 1. Minus 4 times 1 times So good. So 12. Good. Divided by 2 times 1. Now notice, people already picked up on this. If I multiply a negative times a negative, they cancel, right? I mean, they become pluses, don't they? Right. So then we end up with 1 plus or minus square root of 1 plus 12 divided by 2. And I can't really do anything beyond that, can I? I can't simplify that square root. I could just leave it in that form because I don't, if I had i's in my answer, if I had a negative number under the radical, when I have i's, I want to split it apart into 2 different fractions, one real fraction and one, like I get one real term and one imaginary term, right? But if I don't get any i's in my answer, I can just leave it like that. That's fine. So there are both my solutions. Okay, good? Good. All right. Okay, again, quadratic formula, right? So if we use the quadratic formula, so what are my values of A, B, and C? What's A? What is it? What's A? 1.
What the heck, dude? Hey, let's be kind here.
So what do we get then?
X equals negative 6 plus or minus square root.
What's B squared?
B 6 squared. 36.
Minus 4 times
1 times 36. Equals
over 2 times 1. Okay, so if we look inside the radical there, I get 36 minus 4 times 13 is 52, right? So inside I get square root of 36 minus 52 all over 2. What's the square, or what is 36 minus 52? Negative 16.
You said 16. I mean, like the same thing. You have 36. Hell me now.
Okay, what is the square root of negative 16? 4i. Because a negative inside a square root becomes I outside. So that whole thing right here just becomes 4i. So then I end up getting x equals negative 6 plus or minus 4i all over 2. Do I want to leave my answer like that? No. I've got an I in my answer, so I need to split up that denominator. So I get negative 6 over 2 plus or minus 4i over 2. But I can reduce both those fractions, right? So what is negative 6 over 2? Negative 3, and then 4 over 2 reduces to 2. So I get 2i. So those are my 2 solutions. Negative 3 plus 2i or negative 3 minus 2i. Okay, give me thumbs. How are we doing? All right. So far, so good.
So far, so good.
Okay, what's now same kind of thing here, but this time, what do I need to do first? Add the 2. Okay, so first step, we got to push that 2 over to the other side, so I get 5x squared plus 5x plus 2 equals 0. So what are my values of A, B, and C?
5, 2.
And I just use the quadratic formula. So x equals negative 5 plus or minus square root. Okay, 5 squared, so that's 25 minus okay, all over okay, so then negative 5 plus or minus square root 40 or 25 minus 4 times 5 times 2. That's like 10 times 4, so 40. 25 minus 40 is what? 25 minus 40 is, what is it? Negative 15 divided by 10, right? So what is that? Square root of negative 15 is going to become what? Square root of 15 times I, right? The square root of 15, if I make a factor tree out of 15, I just get 5 and 3, no couples. So everything stays inside the radical, but the I does go outside, right? So this whole thing just becomes square root of 15 times I. And so my answers then, now you tell me how I want to fix this. Do I want to leave it like that? I mean, technically that's correct, but it's not the form we want it in. I've got an I in my answer, so what do I need to do? Different fractions. Yeah, I got to split this thing apart. So I get x equals negative 5/10 plus or minus square root of 15 over 10. And I'm going to go ahead and put the I after that second fraction. I could put it in the top, but that looks better. Then I've got my real term plus or minus. My imaginary term looks like a number times I, just a fraction times I. Okay. And what could I do to that first fraction to make things even simpler? Yes. So there would be my simplified answers. Good? Okay. Okay, this one. Do I need to solve the equation here?
Yeah. Like, you gotta subtract 4. No, you gotta subtract 4. You gotta get it all on one side.
Okay, I got to get it all on one side. That's true. Do I subtract 4?
Or no, you should add the 4x and then add.
Yes, I want to push everything to the left side. How come?
That's the proper way.
Good. Positive number of x squared. So first step would be this. I want to take all this stuff and move it over to the left, which would give me a positive 4x squared minus 4x plus 4 equals 0. Okay, so there's my equation. Now, am I trying to solve that equation in this question? You should read the instructions carefully. Don't just jump into these because you might do a whole bunch of extra work and do the wrong problem.
Oh, you just.
So I'm using the quadratic equation, but I don't have to do the whole thing. I'm not really trying to find solutions. What's it tell me to do? It says use the discriminant. Use the discriminant to determine the number and types of the solutions, but it doesn't ask me what they are, right? I don't need to know what they are. What is the discriminant? It's part of the quadratic formula. It's the part under the square root, sure. So if we, in the quadratic formula, where we get x equals negative b plus or minus square root, it's the stuff under the square root. It's the b squared minus 4ac. That's the discriminant. That's what we're interested in, right? So the discriminant d is just equal to b squared minus 4ac. Now let's review what value that has to us. The discriminant. The sign of the discriminant predicts the types of solutions we get and how many. What if the discriminant is negative? What does that tell us is going to happen? No. Raise hands. I want to get. I don't want no more blurting out. I want people raising hands and answering. Yes. Yeah, good. Because look, if I'm getting a negative number under the square root, that means I'm getting i's in my answer, right? I'm getting imaginary solutions. So when the discriminant's negative, they're imaginary, and how many do I get? 2. One for the plus, one for the minus, right? Make sense? So if D is negative, that's giving me 2 imaginary solutions, right? Okay, what if D is positive? Do I get imaginary numbers? No, I get, if they're not imaginary, what are they then? Real, and how many? 2, one for the plus, one for the minus. So again, now we know if D is positive, that's giving me 2 real solutions. Okay, the only other option would be the in-between option. What if D is 0? Then that's, no, I get solution. I get a solution, but look, I get negative B plus or minus the square root of 0, which is just 0. How many different solutions am I getting then? I'm only getting 1 because adding 0 and subtracting 0 give me the same thing, right? So if the discriminant is equal to 0, then I only get 1 real solution. I get the same thing twice, which only counts as 1, right? So all we need to do here is figure out what's the value of the discriminant. So I just need to know what is b squared minus 4ac. Well, what's that give me? What's b squared? 16 minus 4 times 4. I don't need to know the number. What's the sign of that going to be? It's going to be negative. I get 16 minus a bigger number. It's negative. And so what's the outcome going to be? 2 imaginary, right? That's it. That's all they want. Okay. So that's a pretty easy one. You don't even have to get solutions. You just need to know what's the sign of the discriminant and what does that tell you. Okay, this one looks pretty tough, but I can make it easy. How do I do that? Substitution. What would I do here? Good, I need a different variable, so we'll choose x. We started with p's. And look, I get the same thing there. Those are both the same terms inside the parentheses, right? Same factors, I should say. So I'm going to let x equal p plus 2, and then those just become x's. So what is that first term going to be? X squared. On the other side, that one becomes 7x minus 10. And look, I get a simple equation with x's now. How would I solve that equation? Everything to the left. Good. So that gives me x squared minus 7x plus 10 equals 0. I get quadratic equation in standard form. I could use quadratic formula. I always can. But what would be easier? Magic numbers. Yeah. What would they be? Not 5 and 2. Negative 5 and negative 2. Right? Because they have to multiply to 10 and add to negative 7. So what does that make my two solutions? Okay, we done? 5 and 2? Oh, good. I got to go back, right? Got to go back because our original problem has p's in it, not x's. So when we solve this, we need the values of p, not the values of x. So I got to go back and switch those x's to p's. So x is actually p plus 2. So I get p plus 2 equals 5 or p plus 2 equals 2. Well, those are easy to solve. If I isolate p in the first equation, I get 3. How about the second one? 0 if I subtract 2 from both sides. So 3 or 0 would be my solutions. Good? Make sense? All right. Almost there. Okay. So this is the stuff we left off with last week. So I really want to, these are probably really important ones to go through because this is a little bit newer. So solve the equation x cubed minus 13x squared plus 47x minus 35 equals 0. Okay, we wouldn't know how to do that because that's got 4 terms in it, and factoring by grouping would not work because it would fail the ratio test. 1 divided by negative 13 is not the same as 47 divided by negative 35, so it wouldn't work. We would be stuck. But they give us a clue here that's useful. They tell us that 1 is a 0 of f of x. So it's a value that's going to make this left side equal to 0. So if 1's a 0, then that means that what is a factor? So let me remind you, the factor theorem, stuff we talked about last week, we said if k is just a number, right? Any number. If the number k is a zero of f of x, then what goes with that? Yeah, exactly. Then x minus k is a factor of f of x. They always go together, right? If I know a zero, to find the factor that goes with that, I just subtract it from x. So in our case, 1 is a zero, so x minus 1 is a factor, right? And so if I were to divide my polynomial by x minus 1, what would the remainder be if x minus 1 is a factor? 0, right? And we also know that because if 1 is a 0, if I plug it in synthetically, I should get 0 in the remainder box also, right? So this allows me to do synthetic division. What it allows me to do is split this thing up. My original polynomial, I can split it up into the factor x minus 1 and some other factor that I don't know yet, but I'll find out by dividing, right? So if I take my original polynomial and I use synthetic division to divide by x minus 1, well, what number goes out front then? 1. Yep, because 1 is the 0 that goes with the factor x minus 1. And the number that goes out front is always the 0, right, of what I'm dividing by, the denominator. So what's the top row in my synthetic bracket then? 1. And we know that the remainder is 0, right? We know that, okay? So then if I do this synthetic division, what do I get here? If I bring what do I do synthetically? Times by 1. Add. So they add to 0. So look what that tells me. So that tells me that when I divided by x minus 1, that's what I got with no remainder. So isn't that just telling me really this, when I use synthetic division, that tells me the constant. This is telling me the coefficient of x, and that's telling me the coefficient of x squared. So it's telling me I get the other factor, x squared minus 12x plus 35. Okay, that's all I needed, because now I broke this polynomial down into a product of two factors that are small enough for me to deal with. When I apply the zero product property, what do we get? If I apply the zero product property, I get the equation x minus 1 equals 0, or this purple factor, x squared minus 12x plus 35 equals 0. We already know the orange solution is 1. That one was given to us, but I need to find the purple solutions. When I set the smaller polynomial I get through division, when I set that equal to 0, it's quadratic, so it's easy, right? So let's solve that equation. Let's take that purple equation and let's go down here and solve it. And I didn't really even need, honestly, did I need to write this as a product of factors? Not really, because I knew that synthetic division, if I get 0 remainder, this is the smaller part of the polynomial I've still got to deal with, right? After I divide away the solution that they gave me, I have to find the solutions of that. Okay, so that's easy enough. X squared minus 12x plus 35 equals 0. I could use quadratic formula, but there's an easier way. Magic numbers. What are my magic numbers? Okay, and so what are my other solutions then? X equals 7 or 5. Good. And so what are all the solutions? Well, if we look at all the solutions, look, the 1 was given to us, right? The 7 and the 5 we had to find. So, oops. Right, so here was our 5. And there was the 7. And we got all 3 of them, right? We had to find the other 2. Make sense? So because we were given one solution, synthetic division allowed us to make things simple enough we could find the other 2. Okay, let's do another one of those. So number to the right is a solution of that. So what could I do? So x minus 2 is a factor. Good. So we know 2 is a solution. So that's telling us x minus 2 is a factor. So what's the remainder going to equal when we divide? 0. Okay, so let's divide. What are the coefficients I put in the top row? What goes out front? 2. Right? Because 2 is a solution. What's the remainder? 0. So now if I just do synthetic division to figure out, I just need to know what is the smaller polynomial we get when we divide. What do we get?
Bring the 2 down. Have to by 2, 4, plus 5. 10 to 4.
Oh, plus 2. Right?
Plus 2. Yep, 2, 4, 0. Wait a minute. Oh, that's right.
Okay, so now to find my other solutions, I have one solution right there. How do I find the other ones?
Good question. Oh, 2, 5, and 2.
Okay, what do I do with those?
X squared. Wait, do you add them?
No.
2x squared, 5x plus 2. Oh, hold on.
I need to find the zeros of what's left over, right? So I set that equal to 0 and solve. How would I solve that one? Quadratic formula. Yeah. Okay, so then my other solutions, if I use the quadratic formula, what goes on top? -5.
5 plus or minus -5 squared. 25.
Okay, what do I get here? One person, help me out here. Raise hands. Somebody help me out. Okay, let's get somebody different here who hasn't helped me out yet today. John, you're on the spot. What are we doing here? What do I get? B squared. So what is that? 25 minus 4 times 2 times 2. Good. Over 2 times 2. So I get -5. Let's look inside here. That's 8 times 2 is 16. 25 minus 16 is what? 25 minus 16. 9. So I get -5 plus or minus square root of 9, which is what? 3 over 4. Okay, so then x equals -5 plus or minus 3 over 4. So I can simplify those answers, right? I don't have any square roots in my answer. So if I take the plus, -5 plus 3 is -2 over 4. What does that reduce to? -1/2. If I take the minus, -5 minus 3 over 4. There we go. Okay. Get my 2 solutions. Okay. Okay. 2 more. We're out of here. So how about this one then? We're not out of here, but we're done for the year, and then you just get to work. So how about this one? Give me thumbs. Can I isolate x? Can I point to a single x? Yes, I can. It's right there. Right there is a single x, so I can isolate it. Now, what would the steps be in order to isolate that? Square root, subtract 1, divide by 2. Okay, so first step you told me correctly is square root to cancel the squared. So that gives me 2x plus 1 equals what? If I square root both sides, I need
6. No way.
plus or minus. And then the 32, maybe we need to make a factor tree for that, right? So we're trying to simplify the square root of 32. How should I factor that? 16 and 2 would be the best because, no, I don't need to do that. 16 I could break into a couple of 4s. Couple of 4s, single 2. Hey, it's too loud. So I could break it into a couple of 4s, single 2. So then that tells me that my square root of 32, what's the outside part? 4. Inside part? Because couples go out, singles stay in, right? Okay, so then after that, you told me I'm going to subtract 1. Where does it go on the right side? Good, so I subtract 1, and I get 2x equals negative 1 plus or minus 4 times the square root of 2. And then the last step you told me correctly is to divide by 2, which cancels the 2's. And I get it. And now I don't have any i's in my answer, so I could just leave it like that. Okay? Okay, one more. Okay, how about this one? Okay, now look at the original equation there. Okay, the original equation had, what's the degree of that polynomial? So it's 4. So how many solutions should I expect? 4. Okay. How many did they give me? 2. Okay, they give me 2 solutions, so I should be able to divide synthetically with both of those and get remainders of 0. Exactly. Okay, so we're going to have to do that, but we have to set this up a little bit. Am I ready to solve this equation yet? What do I have to do first? Okay, good. I've got to subtract that 192 so I get it all equal to 0. Okay, so that's going to give me x to the 4th minus 13x cubed plus 38x squared plus 40x minus 192 equals 0. Okay, let's take this one first. They tell us that negative 2 is a 0, right? So I could use synthetic division to make this thing smaller. If I divide by the factor x plus 2, I will make my polynomial a little bit smaller, right? Let's do that. Okay, so we can use our synthetic bracket. What number goes out front? Negative 2. What are the coefficients in the top row? And what number goes in the remainder box? 0. Okay, so we can divide synthetically. I drop the 1 down, multiply by negative 2, and add. 68, right? So negative 136, good. Add those up and I get negative 96. Multiply by negative 2. And it works. Okay? Okay, so now that gives us a smaller polynomial. This is my smaller polynomial, but I have another 0. So here's the trick I want to show you guys. I just want to do synthetic division on my new polynomial, right? So why not just make another synthetic bracket right there, right? Drop that down, and that just becomes my remainder box. Everybody see that? Okay, give me thumbs on that. Does that make sense? Okay, this time, what number goes out front? 3. Okay, because I'm really just dividing by the factor x minus 3, which should give me a remainder of 0. So I put the number 3 out front, and I do the same process, and I get a remainder of 0, and I'm going to do the same process again. Okay, so I drop the 1 down. 1 times 3 is 3. I add and get negative 12. So I'm going to get what? Negative 36. I add those up, and I get 32. 32 times 3. Add those up, and I get 0. Okay, now that's great, because now I've got 2 solutions that I already knew about. I already knew that negative 2 was a solution and 3 was a solution. I need to find, gosh, I can't get the right color there. 3 was a solution, and now I need my other 2. Where are they going to come from? Yeah, I mean, because I've got a quadratic factor. I need to set whatever that is, I need to set that equal to 0. Well, isn't that just telling me x squared minus 12x plus 32 equals 0? I just need to solve that equation, right? I could use quadratic formula, but we don't need to. What can we do instead? Magic numbers. So what would they be? I have to multiply to positive 32 and add to negative 12. Negative 8, negative 4. So then what are my solutions? Okay, so then if we wanted to write out all of our solution set here, x equals, okay, so what did we know? We knew negative 2 and 3 we already had. Right, those are the 2 we already had. What are the other 2 I got? There you go. And I got them all. Make sense? That's it. That's it.
Explaining to you what your thought was. Minus 40, right? What's 130?